So the formula that is used for calculating the rational method the formula for calculating the maximum flood discharge according to the rational method is given by QP is equal to CIA divided by 3.6. QP is equal to CIA divided by 3.6. And this is done where QP is what? QP is the flood discharge, or you can say it is the peak flood discharge. It is the peak flood discharge, and this is given in meter cube per second. This QP is given in meter cube per second. Now QP can be denoted as peak flood discharge, or it can also be called as the maximum flood discharge. So it is one and the same thing. Next, what is C? C is the runoff coefficient. C is the runoff coefficient. Now this runoff coefficient, it will be a unitless value because coefficients cannot have a unit. So this runoff coefficient will be a unitless value. And what is I? I is the rainfall intensity, and A is the area of catchment. A is the area of catchment. Now, when you put the rainfall intensity in mm per hour and area of catchment in square kilometer. Okay, when I is in mm per hour and A is in kilometer square, then when you apply this I and A in this formula, you will get the value of QP in meter cube per second. Okay, when you directly apply this I in mm per hour and A in kilometer square in this formula, you will get the value of QP in meter cube per second. Okay, if you apply if you take I in centimeter per hour and if you take A in some other unit like hectare or meter square, and if you apply it over here, then the value might be different. Okay, so you have to remember this formula. QP is equal to CIA divided by 3.6. This is 3.6. Okay, this is 3.6. This thing you have to keep in mind. And I had told you that if you need to calculate the value of I, then for that calculation, there is another formula, that is I is equal to KT to the power X upon A plus B to the power N. Upon A plus B to the power N. Now here, you can take these values, like A can be taken as this TC, or TC is nothing but it is the time of concentration. And here T and TC will be given to you. The value of T and TC will be provided to you. T will be the return period. T will be the return period and TC will be the time. TC will be the time of concentration. Now what is this time of concentration? Time of concentration is the time for the water to flow from the remotest area till the watershed outlet. Okay, like for example, this is a watershed, this is a catchment. Okay, so suppose for example, this is the remotest point P of the catchment. and from this remote point, the water will flow towards the watershed outlet. It will flow towards the watershed outlet. So the time required for the water, for the rainfall water to flow from the remotest point P till the watershed outlet is known as the time of concentration. Is known as the time of concentration. So this formula is used to calculate the value of I. Fine. This formula is used to calculate the value of I in case I is not given to you. If it is given to you, you have to substitute that value itself. But you have to make sure that I value should be in mm per hour. If it is given in centimeter per hour, then you have to convert it to mm per hour. Fine. And a value of A, that is area of catchment, it should be in square kilometer. Please keep this thing in mind. Then only when you substitute it in this equation, you will get the value, or you will get the unit of QP in meter cube per second. The value of QP will be in meter cube per second. Okay. So based on this rational method, we'll solve a numerical. Okay. So this is the problem statement. I hope you can see this on the board. Okay. Here it is written that the intensity, frequency, duration relationship for the catchment is given below. Okay, this is the formula. That is I is equal to 800 t to the power 0.2 divided by Tc plus 15 raised to the power 0.7. This formula is known as the intensity, frequency, duration formula, that which we use for denoting the value of I. As I told you, I is equal to k t to the power x upon Tc plus b to the power n. So here k is 800, t is the value of t you have to find out, or it is given over here. X is given as this, Tc is this, b is this. So this formula is related with this equation. Okay. Now, where I is equal to, I is the rainfall intensity, and that is given in millimeter per hour. T is given in years. T is the return period or the frequency, and it is given in years. Tc is the time of concentration, and it is given in minutes. Assume runoff coefficient, that is C is equal to 0.4. Okay, assume runoff coefficient C equal to 0.4. Estimate 60 years flood using rational method for a catchment with an area of 1000 hectares. Okay, the area of the catchment is given as 1000 hectares and slope of 0.005. The length of travel of water is 900 meters. Okay. Now, in order to, as I told you, the solution for this problem, the solution for the problem will be like the equation for rational method, equation for rational method is given by QP is equal to CIA divided by 3.6. Okay, that is what you have to find out. You want to find out the value of QP. Estimate 60 years flood using rational method. Means you want to find the value of QP is equal to CIA upon 3.6. Now you know the value of C. C value is given as 0.4. You know the value of A. A value is given as how much? C. Catchment with an area of 1000 hectares. So you know the value of A. But you don't know the value of I. I can be found out from this formula, from this equation. Okay, but for finding out the value of I, you need to know the value of this capital T and this TC. Okay, now value of capital T is given to you in the problem. The value of capital T is given as 60 years. Estimate 60 years flood. Hence the value of capital T, so I will write over here as the parameters that is given to you. Okay, now first of all you are provided with the value of T, that is 60 years. Okay, then you have the value of C, that is 0.4. Value of C is provided to you. Next, you have the value of A. A is how much? A is 1000 hectare. But as I told you, value of A should be in kilometer square. So to convert hectare to kilometer square, what you will have to do? You will have to divide this by 100, or you have to multiply it by 10 to the power minus 2. So when we do that, we'll get the value as 10 kilometer square, because 1 hectare is 10 to the power minus 2 kilometer square. Okay, if you want to convert hectare to square kilometer, then 1 hectare is 10 to the power minus 2 square kilometer, and then it will become 10 square kilometer. Then what is given to you? Slope. Slope is given as 0.005. So slope is equal to 0.005. And length of travel of water is 900 meter. Means L is equal to 900 meters. So all these parameters are provided to you in the numerical itself. But you don't know the value of I. C value you can substitute over here. A value you will substitute over here. But you don't know the value of I. So how to calculate I? In order to calculate I, we need to find out this value TC. See, because this formula is given, this equation is given, from this equation you can calculate I. Here when we substitute T, T value is 60 years, it's given. T value is 60 years. So we can put here, we can substitute 60 over here. But TC value we don't know. So we need to find out the value of TC. So TC is found out by the equation given by Kirpich. This equation is known as Kirpich equation. Okay, and with that we can find the time of concentration TC. This TC is known as what? It is called as time of concentration. TC is known as time of concentration. So this time of concentration is found out by Kirpich equation, that is given by TC is equal to 0.01947, L to the power 0.77, S to the power minus 0.385. Okay, this is the basic equation that is proposed by Kirpich, and it is given as this following equation, TC. So here L is the length of travel of water. Okay, that is given to you, and S is the slope. Slope is also given to you. S and L both are provided to you. So just you have to substitute this in this equation. So it will be 0.01947 L. L is 900 meters to the power 0.77. Also S is 0.005. 0.005 to the power minus 0.385. Please mind it, here it is minus. Okay, and here it is a positive value. Here the power is positive value and here the power is a minus value. Now, one more thing you have to keep in mind. This time of concentration value will be given in minutes. Okay, when we substitute the length value in meter, you will get the value of Tc in minutes. Okay, you will get the value of Tc in minutes. And here the value of L is in meter only. Suppose this value would have been in kilometers. Like for example, if this value would have been like 1 kilometer, then you would have to convert it into meter. 1 kilometer would be equal to 1000 meters. So here you would have to substitute 1000 meters. You should not take it as kilometers. You will take this value in meters. So this comes out to 28.18 minutes. Okay, when you substitute this value in meter, you will get the value of Tc in minutes. Please keep this thing in mind. Okay, so this, you found out the value of Tc. Now just you have to substitute this value of Tc in this equation. Now here the unit of Tc is given in minutes only. Here the unit of Tc is given in minutes. So directly you have to put the value in minutes in this equation. So what you will get, we will write that formula over here. I is equal to 800 T. Now here T is given as 60 years. T is known as the return period, or it is known as the frequency or the recurrence interval. It is one and the same thing. So here the return period is given as 60 years. So we will just substitute the value here, 60 raised to the power 0.2. Raised to the power 0.2. Because T is given in years. T is given in years. Here also T is given in years. So we can substitute the value of 60 over here. Next, Tc. So Tc value we got as 28.18. 28.18 plus 15. 28.18 plus 15 raised to the power 0.7. Raised to the power 0.7. So just we have to calculate this value. And this value, it comes out to 130 mm per hour. It comes out to 130 mm per hour. Why I have written here mm per hour? Because here it is given that I is in mm per hour. Fine. If it would have been written that I is in centimeter per hour, then you should have written over here 130 centimeter per hour. Okay. Now next, what you have to calculate? You have to calculate the value of QP. So QP is CIA upon 3.6. CIA upon 3.6. So C value we know. C value is 0.4. I value has to be taken in mm per hour, as I told you before. So that is 130. And A value should be taken in kilometer square. Okay, then only you will get the value of QP in meter cube per second. So this is 10 kilometer square divided by 3.6. So how much this comes out to? This comes out to 144.45 meter cube per second. Okay, this value comes out to 144.4445 meter cube per second. Fine. So this type of problem is very much asked in your university exam as well as your GATE exam. Okay, how to calculate the maximum flood discharge using the rational method. Okay, so we'll take one more problem on this so that you can understand the concept more easily. This is the problem statement. I'll read it out. A small watershed consists of 5 square kilometer of total area. So here capital A value is given to you, that is 5 square kilometer. There is a fall of 22 meter in a water course length of 1.8 kilometer. Now this is a different statement. Okay, I'll tell you how to solve this. The intensity, frequency, duration relation for the area is given by this equation. Okay, it is given by this equation. Now here, in the previous problem, it was given simply capital T, but here it is given as TR. Okay, so it means one and the same thing. And previous problem, it was TC, that is time of concentration. And here it is T. So it is also one and the same thing. That is, you have to take T as time of concentration itself. Where I is in centimeter per hour. You can see here, value of I is in centimeter per hour. Previous problem, it was in millimeter per hour. TR is in years and T is in minutes. So this thing you have to keep in mind. The value of I can be either in centimeter per hour or it can be in millimeter per hour. This T value will be in years and minutes only. TR will be in years and small t will be in minutes only. Okay, as far as I have seen the previous year's question papers, only the value of I could be in mm per hour or in centimeter per hour. But TR will be in years and T will be in minutes only. Okay. Estimate the peak flood for a 25 years frequency. Means here the value of TR is given to you. The value of TR is 25 years. Assume C equal to 0.35. Use rational method. C is the runoff coefficient. So it is to be assumed as 0.35. So how to solve this problem? The solution for this problem will be, first you will have to write the given parameters. Okay, so what is given? A is given, the area of catchment is given as 5 square kilometer or 5 kilometer square. Now this statement is different. There is a fall of 22 meter in a water course length of 1.8 kilometer. Now what will that mean? This means that this fall is like, this is the catchment area. For example, this is the catchment area. This is the most remote point of the catchment area. Suppose this is the most remote point P. And this is the watershed outlet. This is the watershed outlet. So, when it is mentioned that there is a fall of 22 meter in a water course length, means from here to here, the water course length is given as how much? L is equal to 1.8 kilometer. L is equal to 1.8 kilometer. From this point P till this outlet O, there is a fall of 22 meter. There is a fall of 22 meter. Hence, we can calculate. So, we know the value of L. L is equal to 1.8 kilometer or 1800 meter. 1800 meter. Because 1 kilometer is 10 cube meter. 1 kilometer is 10 cube meter. So when we multiply this by 10 cube, we'll get 1800 meter. So we need to calculate the value of slope. Now this slope can be calculated by this fall. The fall is given as 22 meter for a length of 1800 meter. So with this equation, we can calculate the value of slope S. Slope S. So this meter will get cancelled, and 22 upon 1800, or you can write it as it is, 22 upon 1800. Okay. Next, what is given to you? Next parameter that is given is this value T, TR. Here it is given as TR. So TR is given as 25 years. And C, runoff coefficient, is given as 0.35. Runoff coefficient is given as 0.35. So first we need to find out the time of concentration, this value T. Here it is given as small t, so we'll take it as small t only. In the previous problem we took it as Tc. So T is equal to 0.01947, L to the power 0.77, S to the power minus 0.385. So we know the value of L and we know the value of S. So we have to substitute it in this. So it will be 0.01947. L is 1800 to the power 0.77 and S is 22 upon 1800. 22 upon 1800 to the power minus 0.385. So the value of T, it comes out to 34.07 minutes, because we have substituted, we have taken the value of L in meters. We have taken the value of L in meters. When we take the value of L in meters, we will get the value of T in minutes. We will get the value of T in minutes. And slope will not have any unit, because this was what? 22 meter upon 1800 meters. So meter gets cancelled. So slope will be unitless. So this thing you have to keep in mind. Okay. So it comes out as 34.07 meter. So substituting this 34.07 in this equation. Okay. 80 multiplied by TR is given as 25 years. 80 into 25 raised to the power 0.2 whole divided by T. Value of T is 34.07. So this is 34.07 plus 15 raised to the power 0.5. 34.07. Now you see here, this TR value is in years. TR value is in years. Here also TR value is in years. So you have to substitute it in years only. Okay. And this T value is in minutes. T value is in minutes. Hence you have to substitute T value in minutes only. Here also you calculated the value of T in minutes. Hence you have to substitute 34.07 over here as well. So this I, that is the rainfall intensity, it comes out to 21.74 centimeter per hour. Now why I have taken this in centimeter per hour? Because here I is in centimeter per hour. In the previous problem it was in millimeter per hour. So here we will have to take this in centimeter per hour. But we will have to convert it to millimeter per hour. So this, when we convert to millimeter per hour, this will become 217.4 millimeter per hour. 217.4 millimeter per hour, because 1 centimeter is 10 millimeter. 1 centimeter is 10 millimeter. So we have to multiply this by 10. So now just substituting this in the equation to find out the value of peak flood, that is QP is equal to CIA divided by 3.6. Now this I value should be in mm per hour and this A value should be in kilometer square. Then you will get the value of this QP in meter cube per second. You will get the value of QP in meter cube per second. So C, what is the value of C? C is given as 0.35. I is given as 217.4 mm per hour. You should not take this value in centimeter per hour. You should take this value in mm per hour. So this is 217.4 in mm per hour. And A is in kilometer square. A is given as 5 kilometer square. So multiplied by 5 divided by 3.6. So when we calculate this, it comes out as 105.68 meter cube per second. 105.68 meter cube per second. So this is how you have to find the peak flood discharge using the rational method. This method is very much useful to you in your university exam as well as your GATE exam. Okay. So I am preparing you for university as well as GATE pattern both. Okay. I hope you understood these two problems. In case there is any doubt, you can ask me in the comment box.